All right, geology basics. Middle school throwback today. We got some vocabulary words. Yeah, go us. Got a timeline of the Earth's history, major geologic events. You don't need to memorize the numbers unless there's a star next to it. So we've got 4.6 billion years ago, the Earth formed. 3.5 billion years ago is when life was first proven. We have fossils and whatnot. 2 billion years ago is when eukaryotic life became a thing. 65 million years ago was the most recent mass extinction event, which also coincides with the rise of primates and other monkeys. Well, monkeys and other primates. There we go. Nice. We have some special notes here. Life was all single-celled for this part. And up until this part, this time, only 500 million years ago, life existed in the oceans only. So life came about 3.5 billion years ago, and until about 600 million years ago, my bad, it was all single-celled, which is a long time. Right. Oh, and then we've got hominids and modern humans. All right, layers of the Earth. Innermost. This is from inside out. We've got inner core, outer core, mantle, crust. We've got some quick properties of each. The inner core is extremely hot. It is solid. It's made of iron and nickel. It's about 1,200 kilometers in diameter and about 5,700 kilometers deep. The outer core is liquid. It's also made of iron and nickel. It's the only true liquid layer. It's about 2,300 kilometers thick, and it's found from 2,900 to about 5,700 kilometers deep. The mantle. It's divided into two regions. We have the upper and the lower mantle. It's semi-solid rock. It's about 2,900 kilometers thick. It's the thickest layer. It's found directly below the lithosphere. There are two types of crust. We have oceanic and continental. Oceanic crust on average is only about 5 kilometers thick. Continental crust averages about 30 kilometers thick. It's hard, rigid, and the thinnest layer. Why the difference between the two, you ask? The answer is the weight of water. Water is heavy. It squeezes that rock nice and flat. Okay, then we've got plate tectonics. Alfred Wegener is the one who came up with the theory of plate tectonics. His proof was that the shapes of the continents seemed to fit together. Fossils and rock formations were similar on opposite sides of oceans where land critters should not have been able to travel. For instance, he found fossilized ferns in Greenland and mountain ranges. This idea of the Pangea supercontinent that began to break up between 250 and 225 million years ago. And his work became the basis of today's theory of continental drift. We have 15 major plates. We already talked about the two types of crust. Go us. Okay, types of boundaries. We have convergent, divergent, transform. Convergent boundaries are two plates moving towards each other. Commonly used examples of that are the Indian plate and the Eurasian plates. They are smushing into each other, and that's responsible for making the Himalayan mountains. Divergent plates are two plates moving away from each other. Most common example of that is the Mid-Atlantic Ridge. We have North and South America moving away from Europe and Africa. We have plates moving away from each other. Transform are two plates moving past each other, and the example that you should be very familiar with is the Pacific and North American plates in California. They're moving past each other, which is why California has all those earthquakes. Okay, then we color-coded some vocabulary words with the types of boundary. They were color-coded, so take a minute, pause, read those. I don't feel like rewriting them. Okay, that's enough. And then why do volcanoes and earthquakes tend to be found on plate boundaries? It's thin, weak points between plates. Magma is close to the surface. Good times. All right. Then we had some case studies. All right. Earthquakes. They're measured with the Richter scale. It is a logarithmic scale, which means a change in one number is equal to a difference in power of a factor of 10. Your example here is that a 4 on the Richter scale is 10 times stronger than a 3 on the Richter scale, which means a 5 would be 100 times stronger than a 3. And that leads to our question, How many times greater in magnitude is an earthquake that is a 7 as opposed to a 3? It is 4 steps from 3 to 7, so 10 to the 4th, or 10,000 times. We skipped the focus and the epicenter, but if you're curious, the focus is the point in the Earth's layer where a break and a fault happens. It's the actual origin of an earthquake. The epicenter is the focus, but moved that point up to the surface. So rather than happening inside the Earth, the epicenter is at the Earth's surface. Great. And yeah, then we had our Oreo activity. Right, we've got the Ring of Fire. The Ring of Fire, it's a series of volcanoes around the Pacific Plate, has lots of earthquakes, 75% of all the world's volcanoes and 90% of the world's earthquakes. If you look, it looks a little bit like an incomplete ring. We'd have to kind of finish it off right there, but that's okay. It's close enough. Okay, types of rocks. We have igneous, sedimentary, metamorphic. Each one has ways that it forms, some examples, and unique characteristics of them. Take a moment, make sure you read those. You do not have to be super familiar with them, but make sure you have a passing understanding of them. One important thing to point out is that sedimentary rocks are the only ones with fossils. The fossil samples get destroyed in the formation of metamorphic and igneous rocks. Right, we have the rock cycle. We're not going to talk about this because this is very middle school, but make sure you are familiar with it. And then we have Pangea. Here are those matching fossils that Wegener had noticed. You have these lizards and frogs that are found in both South America and Africa, but neither frogs nor lizards can swim across the Atlantic Ocean. Here in particular, these are remains of an old type of fern. Ferns definitely can't swim across the Atlantic Ocean. They're known for being very lazy.